One of the most important tools I have in my toolkit is what's called a digital multimeter. I probably use these about second only to my Phillips head screwdriver, and I've used them to fix a lot of different things, from my boat to my refrigerator to many other different electronic devices within my house. So in front of me I have a few different types. These are like what are called the auto ranging, so they automatically adjust the range to what you're measuring. This right here is a manual ranging. These tend to be the cheaper, usually cheaper, less expensive ones, but they're not as user friendly, and I'd say avoid these. Um, this one right here was great to fix my fridge. What I did is I put this around the hot lead of the compressor and plugged the fridge back in, and I set this little max, and it showed me the max current draw, and I noticed that it looked like the protection circuit of the starter relay was kicking in too soon before the compressor was turning on all the way. So what I did is I replaced the starter relay, which included that protection circuit, and it started up fine, and it's been working great ever since. These two are my favorite. By far the ones I use the most. This one is about $120, $120-ish multimeter, and it's a EEVblog, which is branded for David Jones' little EEVblog channel. It's a great source if you want to learn about electronics and basically anything to do with electronics. I mean, check it out, definitely. And I wanted to support his channel, and I wanted a decent multimeter from a reputable brand, and that's why I got this one. This one over here is an AliExpress cheapo. So I was actually very impressed with this. Only $35, and it pretty much does everything that this does. The brand isn't a real well known brand compared to this one, but it's called the ANENG or ANENG. I don't ANENG, and it's the AN 870. That's the model, and I like this one a lot. It first of all came with a nice little selection of cables. Pretty much most of these came with like a temp probe. So, and what I really liked about this one, it came with these little alligator clips, so you can connect it to whatever you're trying to measure, and you can use plug a probe into the other one. And this is really nice when you're trying to use things where you need more than two hands a lot of times. So it came with a little case as well. I forgot to mention that the EEVblog meter came with some really great leads. These are made out of silicone, which are nice, so you don't have to melt them when you're soldering and you accidentally hit it. So I mean, I do like these, and they're kind of like how they feel. So we call these multimeters because we do like to measure multiple things. So it can measure current, amperage, which is amps. It can measure voltage. It can measure a lot of different things. So right here we can measure voltage and AC. That's what that squiggly little line is right here. We can measure voltage in DC, millivolts, temperature, and you also have resistance, which is measured in ohms. It has also measures capacitance, which is that little, I guess, shape right here. Then we have a diode tester, which is, I'm going to show you guys how to use that, and also continuity tester, which is probably one of the most common things I use. We also can measure current with amps, milliamps, microamps, as a non-contact voltage meter, and these can be done in both DC and AC. 19,999 count, and what that really means is that's how many characters can be displayed. If you take a look at EEVblog one is about, I think, 7,000 count. I forget. I'll probably label it somewhere. So this one can also do a lot of pretty much the same thing that these can do. One thing to note about these multimeters is that you see all these different little plugs right here where you can plug things in. The black and where you see common, that's where you plug in the black lead. That's for your ground. So you can see this one is yellow, but you can see COM, so this is common. So that always means your ground. Same thing here, common. So the nice thing about these two, and compared to a lot of other ones out there, they have the measuring for current, the amperage, on separate pegs. So if you plug it in, you don't actually switch to the wrong You don't switch by the wrong thing and damage your device. So it's nice that those are completely separate. So what you do is, if you want to measure current, you plug it into these two, and based off you're measuring amperage or milliamps. These are both fused, so if you're going to measure something with much higher amperage, you're going to use this one here and this one here. But like if you're going to measure like something like I do, which is mostly low voltage, low current, then you're going to use these. So I'm going to show you how to use some of these. Right here I have two LED strips. They're kind of similar in the fact that they're both common anode, which they have plus voltage, and then GRB for the three different cathodes. The big difference between these two is one uses a 12 volt supply and the other one uses a 5 volt. And this 5 volt one is actually different than your addressable or digital RGB strips, because this one has a little integrated circuit, which is that little black speck of dirt that you see in it. Well, this one doesn't. And this also uses 3 leads, and these both uses 4. So completely different. They just, only thing common that these two have are just a voltage supply. When we look at these, you can see that, you know, they both look similar, but there's a little bit more to them. Interesting enough that the little LEDs on them are actually the same type. So if you can see right here, I'm on what's called a Diode Tester, and you can also do what looks like capacitance above, but I have it set to use a Diode Tester. So what we're going to do right here is we're going to measure what's called the forward voltage, and the forward voltage is the voltage that is used to make the LED come on. And so this is a diode tester. So what we're going to do is I'm going to set the positive to anode, and I'm going to touch each cathode of the LED, and you're going to see that every different LED I touch, different lights come on. So green is 2.2, red is 1.7, and blue is 2.5. So remember those numbers. So now we're going to come over to this little 5 volt strip, and I'm going to do the same thing. And, you know, green is 2.2, red is 1.7, and blue is 2.5. What about that? I mean, they both have the same forward voltage. So what that means is that these are basically the same LEDs. I could literally remove these and then solder them onto, switch them around, and they will work exactly the same. Measure the resistance and check these different resistors. So you can see that even though this is strip of 3, strip of 1, they both have 3 resistors. So this is 150, 330-ish, 150, and this one is 330, 330, and 180. So if you didn't notice that this 5 volt has higher, the resistors on it have more resistance than the ones on the 12 volts. That's how you use ohms to measure stuff. So what I'm going to do is I'm going to switch to what's called continuity. And what continuity is, gives your little meter a little, you touch the two little leads together. Where am I? Okay. And it beeps. So that tells you what things are connected to. If I put the 12 volt to 12 volt and I check for continuity, I have it. If I check the green, red, and blue. So there's continuity, and it's going to be the same thing for this little one right here. So what we can also do is check continuity. Like for example, it doesn't really matter which way you have it. So each one of these is connected to 12 volt. If you come to here, hey, they're not. So what's with that? Well, what that means is that these LEDs are wired in series. So each common anode, each one's connected to the other one, while all 3 of these are connected to the plus 12 volt. And the reason why is because they're all being supplied the same 12 volt, and if I connect this to this, you can see that there's continuity there. So that's how I know it's wired in series. And I can't get any continuity between this because it's currently not on. Then from there you do have your little resistors. So let's see where the resistor is connected to. let's see where, maybe it doesn't matter. Okay, so it looks like it's off the first one. It doesn't really matter where you have the resistor in the circuit. It just has to be, you know, inside of it, inside of it somewhere. You can put it in front of the LED, behind the LED. And the thing is, you need different LED values because these LEDs are not. LEDs aren't current limited, so they'll just, if you supply them with 12 volt, or if you supply them with the 12 volt, they'll just suck all the current that they can eat and just blow up on you. So they'll die pretty quickly. So that is why we use resistors, which are called, we call them current limiting resistors, to prevent them from dying. And you know, those are different ways you can play and kind of play with LEDs. You know, I also have my little PCB here that I designed, so I can tell, you know, what's the ground plane. So so you can just test on a board, see what's connected to what. Then you have, you know, check for voltage. So you can, there's a lot you can do with these things. I mean, you can use it to test a lot of things. On my fridge, there's some, when I was looking up some reviews, they said to check for resistance between the 3 different pegs on the compressor, and the resistance values to match. So you can use resistance as a way to see if something's in spec or if it's not. They also said if there's continuity between certain things, and that means it's broken. So there's a lot of ways you can use with a digital multimeter to solve a lot of your problems. And you know, these things are great. I mean, you should, you know, honestly get something like this. I mean, this was $35 from AliExpress, and you know, the fact is that it was so cheap. I basically bought 5 of them and gave one to each one of the guys in my family as a gift for a special occasion. So, you know, I really wanted to kind of do a little roundup of, you know, things I've learned about these multimeters, and I hope that you pick the right one. Don't make make mistakes like I've done in the past by getting the wrong one. Just, you know, $35. This is a great one if you want something from a better, you know, brand and help support David Jones' channel. I mean, these are great, and they come with a nice silicone lead so you don't burn them. This also comes with some great stuff. If you like content like this, feel free to subscribe, give a thumbs up. If you have any questions, feel free to ask. I'm definitely not an electronic engineer. I'm a Linux system engineer, so quite a bit different, but I'm trying to learn this and trying to share my interest and what I've learned with other people. So thank you for a wonderful evening. Good night.